Hi there, this is a part one, it's going to be in two parts, of a mistake I made when I was fitting a Baxi 800 Combi boiler and Hive controls, Hive smart controls. Bit of a, not a disaster, but stuff that's not out there that should be out there. So when you're buying this stuff and you're doing your research, you know, you can find the information and make sure you get the right equipment. So having recently moved house in autumn 2021, we moved to a detached bungalow, and it had electric central heating, those smart electric radiators. I think they were run IDs, lovely things, but obviously electric. And looking at the pending energy price increases, you know, we were looking to make sure that we didn't get, well, I think everybody's going to get caught, but get caught to the least amount possible. So fortunately at the property there was no gas meter, but there was a gas pipe, and it did have a gate valve on it and a cap, so I checked with the utilities, and yes, there is gas at the property. I just have to organise to have a meter fitted, which is quite a painless process. So I set that up and running, and then also looking at the price per kilowatt hour of electric and gas. And I'm going back now to, I think it was probably August or September 2021, the ratio of gas price to electric price, and I think we were on EDF Energy at that time, was actually 3:1. So electric was 3 times more expensive than gas, or gas was 3 times cheaper per kilowatt hour, you know, to use it for heating the house. So we're going to radiators out, and let's get some quotes in for gas central heating. So there's only 2 of us in the property. We don't need a lot of constant hot water, so we were looking at a combi boiler, plus the fact there was a lovely big cupboard space in the kitchen which we could use, or my better half had something planned for that, where the copper cylinder resided. So copper cylinder out, big space gained, and also I'm going to do a bit of work in the loft, and would have got rid of the header tank in the loft. So yeah, that was the way to go. Combi boiler and gas. Let's see what happens. So phone round, got a few, well, I got 4 quotes. No problem with getting the quotes for the heating system. Unfortunately, because of the times, with just coming out of lockdown and the work that had stopped during lockdown, and the work that had been pre-booked to happen in lockdown was all backlogged, so there was no way that I could get anybody, even though we had the 4 quotes, to fit my gas central heating before the winter. Little bit, could have kept with the electric radiators, no worries, but let's go to plan B. So I thought, well, I can, you know, I'm pretty handy, I'm an engineer, you know, I've done a lot of plumbing work, I'll have a go myself. So I purchased the boiler, a boiler fitting kit, flue, etc., AD Magna water filter, boiler controls, all type 22s, K22s for the radiators, maximum efficiency radiators. I was going to do it all in copper, so copper pipe fittings, and I tried to get it as a package deal from a local plumbers merchants who we've done business with in the past and done okay by him. He's treated us quite well, so try and get a deal off him for this package. No problem, so I just had to work out now exactly what I needed. So from the 4 quotes, they all came with different boiler capacities. Some are far more expensive than others, and it wasn't just relating to the boiler size. British Gas being far more the most expensive, but probably, British Gas may have done the best job. Certainly probably better guaranteed work, etc., that type of thing. But the boiler sizes, the smallest boiler was 25 kilowatts and the largest boiler I think was 38 kilowatts. So obviously I need to get this bit right. So I had a read up of how to calculate the heat loss in a house, and there's a couple of download bits of stuff you can download. I think one was an Excel spreadsheet. Anyway, I did a bit of maths, did a bit of downloading, worked out some U values, room sizes, floor types, wall types, insulation, window sizes, etc., etc. And I came up with a figure of, I think it was, the figure was 5,500 BTUs. So doing the conversion to kilowatt hours, it came out just under 17 kilowatt hours. So if my smallest boiler in the quotes was 25 and the biggest was 38, I've probably done something wrong here. So I'll go and redo all the measurements, and I actually found another online calculator. I think it was Worsley or something like that. So recheck my sizes, wall types, inners, outers, insulation, window sizes, double, single glaze, U values for all the rest of it, and the figures came out, not a million miles away, came out to 57,300 BTUs. So the 17 kilowatts was correct. So why we're over-speccing boilers, I don't know, but I suppose it's better to be over than under, so maybe there's a bit of safety margin that heating engineers build in there, I don't know. So yeah, I'm looking for a 17 kilowatt boiler, but we're looking to build an extension maybe next year or the back end of this year, make a start of another room, another bedroom and a small study, and I'm going to need another 3 radiators. So I've went for a 20 kilowatt hour boiler. So it's 20 kilowatt hour on the central heating side and 30 kilowatt hour for the hot water. Built that into the deal. Also the smart controls, important bit. So looking at the quotes, one of them was a bespoke control. I think it was a Wiesmann or something, quite expensive control. But the other 3 were this Hive smart controller, which also was the British Gas one. British Gas actually promotes it, so it's got to be good stuff. So we'll go for a 20 kilowatt Combi boiler, 30 kilowatts, hot water, 20 kilowatts, central heating, Hive smart controller. Worked out my 9 radiators, my sizes. So 9 radiators, 1 heated towel rail, 60 metres of 22 copper, 40 metres of 15mm copper, about 20mm of 15mm John Guest plastic, because it's a bungalow, so all my loop was in the top, and the runs to the drops were in copper, but all the drops I ground the walls out with a disc cutter and put the pipes in the wall, so they had to be done in plastic, obviously, because of the lime and the cement and all the rest of it. It's not very kind to the copper, so copper everywhere apart from the drops, which were plastic, and then into the radiators. Took me about 2 weeks because I did I wanted everything to be neat and tidy and hidden, and pretty smart. I was quite pleased with the end result. The only thing I couldn't do, obviously I had the boiler installed, I had the gas meter installed by EDF at the time, no problem. I think they did it within, phoned them up 4 days later, it was in and done. But I couldn't do the gas run into the boiler and obviously I've got this 10-year warranty with a Baxi boiler. I needed to have the gas boiler correctly commissioned by a gas safe engineer to get the warranty. So again, a great deal of phoning round, bad time of year, etc, etc. I did manage to get a gentleman, a gas registered heating engineer. Unfortunately the nearest one I could get to come was in Devon, which is 100 odd miles round trip for him, but hey ho. And unfortunately he was so busy he could only do it on a Saturday, so a little bit more expense, but gas all piped up, set up, boiler commissioned, all signed off, spot on, very happy. So now my bit again, I'm now going to set up my timer, temperatures, etc, etc on the boiler. So my Hive is wired in and I've got it talking to my nano hub. Set my target temperature for the room of 20 degrees, and I went for a central heating water temperature of I think it was 80 degrees, and then I start to look when I'm connecting and wiring the Hive that it is just an on and an off device. The only thing that makes it smart is the fact that you can obviously connect it by Wi-Fi. You can connect it to your tablet, your smartphone. You can go to the pub and you can turn your heating on and off in the pub and adjust the temperature. But it's not a smart control, so it wasn't going to do the job. I was a little bit disappointed because obviously that bit was, I think it was 175 quid for all the bits and pieces that go with it, but it is just an on-off dumb device. So you set your target temperature, it gets there, it goes open circuit, turns the boiler flame off and cools down. I don't know what the high stress is. There will be a high stress on it, obviously. You may have to drop down by 1.5 degrees before it sets the boiler back on, but that is definitely not what all these smart boilers are about. So I've now got a smart boiler with a dumb controller. So now back to the paperwork, get my Baxi installation manual out, and I'm looking for this, the smart control connections, etc. And there's about 6 lines, and it's something called OpenTherm, and it's another set of it's another terminal block which is connected directly onto the printed circuit board, and there's a couple of terminals on there, OT1 and OT2, obviously OpenTherm 1, OpenTherm 2, and it's a standard which not all boiler manufacturers use, but most of them do use this standard because they all have to have this smart technology built into them. And it would be nice if you could use it, but you're definitely not going to be using it with a Hive thermostat. So I was interested in this smart technology of the boiler, so I did a little bit more reading of that. So what it allows the boiler to do, even though I've got an oversized boiler, I only need a 17 and I've got a 20, instead of the boiler firing at 20 flat out until the room's thermostat goes open circuit, I hit my target temperature, room starts to cool down, and then it kicks back in again, so you've got this blast of everything and then nothing, and it creates this, they call it, it's called cycling, and there was a little bit what they call overshooting and undershooting of the target temperature. So you've got, now I've picked a room temperature where my thermostat sits at 20 degrees. So the boiler fires 20 kilowatts, woof. I've got my water temperature set to 80 degrees. I'm now blasting this hot water around the radiators. Obviously now I'm introducing from the radiator the hot air into the room. The air starts to get hot and your Hive thermostat sees this 20 degrees reached and click, it goes open circuit, and it only turns off the flame. The pump's still running. So there's a lot of latent heat, hot water, hot heat exchanger still left in this system, and it's going to carry on being pumped around. So what happens is the room temperature will go above the target temperature because of this latent heat, which you've still got to get rid of. So it still ends up warming the room up beyond the target temperature, and this is this overshoot situation. And because there's a hysteresis, or a differential between a cut-in and a cut-out value, temperature value of a thermostat, and it may be 1 or 1.5 degrees, the room has to go below the target temperature before it will send a signal to switch back onto the boiler to relight the gas. So in this period, it ends up going below the target temperature, and it's now going to heat all this water back up again. So I've gone over and I've gone under and I've created this cycling effect, which is not what a smart boiler is all about. So I just trying to use it as an analogy. If you were on the motorway and you wanted to get this 45 miles an hour, 45 miles to the gallon out of your Ford Fiesta or whatever you're driving, and it says if you drive it at 60 miles an hour you're going to get that 45 to the gallon. So even though the boiler's capable of delivering this sweet spot, and your car is probably capable of doing it as well, but if you put your foot on the throttle so you go up to 70 miles an hour, or I've gone 10 miles an hour over, and you take your foot off and the car slows down to 50, or I've gone below the target speed, and you put your foot back on, so you're doing this, over time you will have still achieved your average speed of 60 miles an hour. Obviously the difference between the 70 and the 50, but there's no way that you're ever going to get your 45 miles to the gallon. And it's the same with the boiler. You're cycling it beyond, and you're cycling it's going below, and you're creating this massive heat dump, then massive heat loss, massive heat dump, and this cycling effect. So you're going to be burning a lot more gas, and it's not going to be kind on the boiler, because the boiler doesn't like, if you can find the sweet spot. Let's say now we're going to use the cruise control on the car to find this 45 miles to the gallon with the 60 mile an hour. So I gently bring my speed up to 60 in the car on the motorway, and then I click on my cruise control, or I use my foot very carefully on the throttle and I hold it at 60, and I do my 100 miles or whatever you're driving to. I'm going to get my 45 to the gallon, no problem. And the boiler is also capable of getting that extra bit of value, the 92% efficiency from the boiler, by doing it in a similar way. So I had a read up on that. What is this smart boiler technology, which they all have to have built into them now to be able to be sold in the UK. So the gas valve becomes proportional. So instead of it just opening and closing, the gas valve can proportionally open, proportionally close, be held at a sweet spot. And the fan blower motor, which goes in with the gas, is now controlled, motor speed is controlled proportionally to the opening of the gas valve. And also your central heating pump motor is also now on a variable speed, and it's all done with this PWM, pulse width modulation. So instead of the motors running off the mains frequency, direct electric, which is 50 Hz, which would control the motor speed for the fan motor and the central heating pump motor, we can now control them infinitely with this PWM, pulse width modulation, by changing the frequency to whatever value you want. And it's all done inside the boiler on a smart microchip on the printed circuit board. Unfortunately, if you've got a dumb thermostat, you're not going to be using any of it. So this is the bit that I got wrong with not doing my homework properly. So we now know what the boiler's capable of doing, and now just need to extract that extra bit of efficiency from it. And it's not going to be with a Hive thermostat, which may be smart in the fact that you can have it on your phone and turn it off anywhere, on and off anywhere in the world, and adjust the temperature. But we need to send information into the boiler directly into those OT1 and OT2 terminals to make it work. So instead of just a hard signal going in of an off and an on of a temperature thermostat clicking on and off, it's now reading the actual temperatures inside the room. And because the boiler has a temperature probe on the outgoing flow of the water system, central heating water system to the radiators, and has another one on the return side, the boiler can also see the differential of water temperature of outgoing and incoming. And this is where we're going to just talk about this delta T, which is another thing I read up about. So to be able to use all this stuff, we need to find another smart controller. So I could actually Baxi make their own, and it is a lovely bit of kit. There's a few components in it, and it's not cheap because it's probably good stuff. But there was another piece of technology with a smart thermostat, and it's also actually a learning thermostat as well. It will learn your habits, it'll learn how long it takes for your room to warm up, how long it takes to cool down, because a lot of latent heat is actually stored in the building itself. If you've got inner walls which are block, that becomes a radiator. So it looks at all these different values, and it makes a determination of the best level to bring this water temperature up to maintain this air temperature, whichever you want, where you've put your thermostat, whatever you've got it set to. So now we've got this boiler which can modulate now right down from 20 kilowatts down to 5 or 6 kilowatts, so it can run very low without switching on and off. It can now fire up and start to rise up to the target temperature, and when it gets to near your target temperature, it'll start to ramp off. The gas valve will start to close, the boiler blower fan will reduce, and we may even slow down the central heating pump motor to slow the flow of water down. And it's going to hold it right on that 20-degree line. So that's what I was looking for, and the device that I ended up buying, in fact I'll just go and get it, I just bought it actually. Okay, it was coffee time as well. So, this is our Hive stat, and this is the Hive control, which is going on eBay because I won't be using that for anything else. Beautifully made bit of stuff, really. The Hive, I've got Hive camera, some Hive switches, I've got the nano base unit. It really is well made stuff, but it's not a smart thermostat. So this is the baby. This is the Nest E, controlled by USB, so you do get the little power supply or transformer with it as well. So you're going to site this in the room where you're going to set your target room air temperature to, and this is the device that it talks to Fancy bit of cover on there. Yeah. This you can put in place of the old thermostat, and I'll have to, because obviously now I've got holes in the walls and I've just plastered and painted, so this will be going back in place of that. But you could put this right next to the boiler and just have a metre of wire going into the boiler. You don't have to bring this into the room where you want your target temperature to be, because it's done with this, and this sends its signal Wi-Fi to this, and this doesn't even need a power supply. This is driven by a couple of AAs and I think the lithiums, so you know they're going to last a couple of years, and obviously when they want replacing it's only cheap. And looking through the instructions, you can scroll through the display, and there's an area on the display that'll tell you what this battery voltage is. So like when it gets down to 2.75 volts, get a couple of new batteries, but they're going to last a couple of years because it isn't doing anything. You know, this is where the electrical connections are made. So this can also be a thermostat as an on-off, whether it's got a normally open or normally closed, common normally open, normally closed terminals on one side, but on this side we've got our OT1 and OT2, OpenTherm 1, OpenTherm 2, which is going to be wired straight onto the second connection strip in the Baxi boiler and straight into the circuit board. So we don't want any mains voltage going anywhere near this. So you got to be, if you are swapping one out, be very careful, because if you put 240 by mistake from this unit by connecting it up incorrectly into that printed circuit board, you're going to be buying a new circuit board and it won't be being done under warranty because they'll know that you've fried it. So there are no or very low or no voltage contacts. It's just data streams back and to, and which is monitoring all the information that this is learning about your habits, about the room, how long it takes to warm up, how long it takes to cool down. And another thing which is quite good about this, weather compensation. I mean, I actually have got the weather compensation probe, which you don't even have to drill any holes in the wall or anything. It actually goes on the in-feed of the boiler flue into the boiler, and that also connects onto the M2 connector strip. But I don't even need to use that because this also will now do weather compensation. And as long as you're not in the bottom of a valley or on the top of a mountain somewhere, you're in a general area where when you read the weather forecast, I think it takes its information from 3 weather stations, triangulate or whatever, and whatever the ambient conditions are on the internet for your postcode and address, because where you have to put your postcode and address in this system, it uses that outside information, outside ambient temperature and humidity information, as a weather compensation device. So when you did your calculations, your heat loss calculations, you do it at worst case scenario, and well, you know, it might be -10 if you live in the Western Isles of Scotland or something, I don't know. But down here we're never going to see anything, hopefully, less than -4. So as the outside air temperature drops, then this will also step your boiler up a little bit more to try and maintain your nice 20 degrees even flat level temperature in the house. So I've got high hopes for this thing, and next week we'll be fitting it, and I'll video it and see how we go. So till next time.